Hi, welcome to everyone to the lecture 2, which is of structural systems, in which the structural system in which the outline of this module, as we have already discussed, that introduction part and type of structure and forms. Now today we will discuss about the aspect ratio and overturning resistance. Then later on we will discuss that strength and stiffness. So aspect ratio. What is the aspect ratio? It's the length divided by its width, both in plan of a building is termed as aspect ratio. When a building is in a plan, then its length is divided by width, or the ratio of length to width of a building in a plan is called aspect ratio. And here is the another term, which is a slenderness ratio. So the ratio of height to least lateral dimension of a building is termed as slenderness ratio. So what is the mean of least lateral dimension? So when the building is in a plan, then its smallest dimension of the building is called least lateral dimension, that is a width. So now in aspect ratio, why we are going to study this aspect ratio and how the aspect ratio will affect the building or building load carrying capacity. So here is the definition. It's not good to have a building with large plan aspect ratio. During earthquake shaking, the floor slab in building with large plan aspect ratio, which is a greater than 4, may not provide rigid diaphragm action. So here is a new term, which is a rigid diaphragm action. So before going to the definition of rigid diaphragm action, I'll explain you that how the floor slab will play a role when a building is subjected to an earthquake. So during earthquake shaking, inertial force is mobilized in a building, usually at the floor level, and where the concentration of mass is large. So at the floor level, the concentration of mass is large, so the inertial force will be mobilized by the floor slab. This inertial force then distributed to the different lateral load resisting systems. And what are the lateral load resisting systems? These are the columns and structural wall and or shear walls. So this inertial force is distributed to the different lateral load resisting elements to their resisting capacity, and this is achieved when the floor slab do not deform too much in their on plane. So here is a aspect ratio is greater than 4, means the length to width ratio will not be a greater than 4. It should be equal to 4 or less than 4. And the definition of rigid diaphragm action is when the floor slab helps in distributing inertial force to different lateral load resisting systems, that are columns and structural walls, in proportion to their stiffness, is known as rigid diaphragm action. So proportion to their load, their stiffness means load required for a unit displacement. So all the load resisting systems or elements which are columns or shear walls having different stiffness or different their cross section, according to their cross section, their stiffness will be a different, so that the inertial force will be distributed among which in the proportion of their stiffness, and this is called a rigid diaphragm action. So here another definition is IS 1893, which is Indian Standard Code of Practice for criteria for earthquake resisting design of construction, is preferred to restrict maximum lateral in plane displacement of a diaphragm at any point to within 1.5 times the average displacement of entire diaphragm for a good performance of the building. So IS 1893 prefer that the maximum displacement of a diaphragm at any point is limited to 1.5 times the average displacement of the entire diaphragm, and this can be achieved by if the building aspect ratio is up to 4. So in this condition, the floor slab helps in distributing the inertial force to different lateral load resisting system in a rigid diaphragm manner. So for that, here are some images or figures which shows when a aspect ratio is limited to 4 or less than 4, then the floor slab will perform in a rigid diaphragm action manner, and if the aspect ratio of a building plan is greater than 4, then the floor slab will tend to flexural bending, and it may not distribute the mobilized inertial force to different lateral load resisting members. It can deflect in a flexural bending manner. So in this picture it is clear that if the aspect ratio or the length to width ratio is less than 4, then the rigid diaphragm action will occur, and if the aspect ratio is greater than 4, then the flexural bending of floor slab occurs, so that they cannot transfer the load to the lateral load resistance system in a good manner. And this figure is taken from the a manual which is some concept in earthquake behavior of a building and published by Gujarat State Disaster Management Authority. Now another figure is showing when the aspect ratio of a building is going on increasing, then their absolute lateral displacement of diaphragm along the building length is also going on increasing. So for that, the Gujarat State Disaster Management Authority have considered 6 5-story buildings with a different aspect ratio of 2, 1, 2, 4, 6, 8 and 10, as you have seen in this figure 1, 2, 4, 6, 8 and 10. And they performed some experimental studies and found that if the aspect ratio of a building is going on increasing, then the absolute lateral displacement diaphragm along the building length is also going on increasing. Another figure, it is showing that I have already discussed that the IS 1893 is preferred to restrict the maximum lateral in-plane displacement of a diaphragm at any point is to be within the limit of 1.5 times the average displacement of the entire diaphragm, and if this condition is satisfied, then the building will perform good in a seismic behavior. So this can be achieved if the building aspect ratio is up to 4. So from this picture it is clear that if the building aspect ratio is limited to 4 or less than 4, then the ratio of maximum displacement to average displacement is 1.5, and if the aspect ratio of a building is going on increasing and its maximum is up to 10, then the ratio of maximum displacement to average displacement at ends will be equal to a 7, which is not a good practice. Another thing you can see from this picture, that the 3D view of a building and a plan view of a building, if the aspect ratio of a building is going on increasing, then the flexible diaphragm action will occur instead of rigid diaphragm action. Next, what are the advantages of an aspect ratio? Instead of, I will discuss before, that are 2 advantages. That correct aspect ratio improves energy performance of the building, and second one is the correct aspect ratio can minimize lighting load, thereby saving energy. If the correct aspect ratio has been chosen, then it improves the energy performance and can minimize the lighting load, so thereby saving in energy and cost. So now overturning resistance. Before going on overturning resistance, here is I'll discuss about the overturning. What is the overturning? So overturning of the structure is caused due to the lateral forces. When a building is subjected to any lateral forces, then the overturning in a structure will occur. The various type of lateral loads acting are as follow. So there are two type of lateral loads. We are considering that wind load or a seismic load. So when a structure are subjected to lateral force such as a wind force and a seismic force, they undergo deflection in a lateral direction and a lateral sway is also observed in one direction of the structure. This causes structure to experience overturning, and how this overturning will prevent is called a overturning resistance. So to resist overturning movement, there is a resisting movement on a building opposite to overturning movement. So to prevent this overturning, we will apply a movement in the opposite direction of the overturning. It cannot, so that the building cannot overturn, is called overturning resistance. This can be clear from this picture. If any building is subjected to a lateral force which is F, then it tried to overturn the building in a clockwise direction. And if we provide M stable, which is a resisting movement in the anti-clockwise direction, then the building cannot overturn and return to its original shape, and this is a overturning resistance. So here are some example of overturning. Due to overturning, the building failures will occur. This picture shows that overturning failure of apartment complex building during Niigata 1964 earthquake. So here are some references that has to be preferred to prepare this slide. You can refer these references, and thank you for